Hey guys, so this is going to be the second video in what's becoming a bit of a series on me modeling up some skate gear that I might eventually make or not make, but mostly just modeling it for fun. So first of all, I found my board and set it up with some of my old precision trucks. This is a fresh set of trucks that I had never taken out of the box. So yeah, they're looking all nice and lovely, with a nice set of wheels on them that have been used before, but they're pretty much new. Um, while I'm talking about those, have a look at this. This is the original model that those trucks got made from. Pulled it off an old bit of communication that I had with the guy who was machining these up for me. But yeah, that's what it looked like. So this video I'm going to focus on wheels. So I've wanted to model up a wheel for quite a while, and while I've been away from the skate scene, it seems like these really well supported core wheels have come into fashion, or have proved to be really great. So Rad Wheels seems like they were the first ones to do this. They actually came out just while I was stopping skating a lot, and yeah, so I decided to base the model of the wheel that I make based on what they have. I don't have any reason to change it, and I wanted to model a wheel, so hey, it was a good place to start. So I found this image, which is a cross section of their wheel. It's got what they call their crown core, and you can see it's in their branding. So obviously, I think it's pretty cool. You can see that this center crest is the same height as these outside walls, which means that they can't do a couple of things, like they can't have mechanically interlocking holes for the urethane to go through the plastic injected core like a lot of other wheels do. Like a lot of ABEC 11s wheels have holes through the side of the core for the urethane to bite into, but these wheels would have to rely on the chemical bond or micromechanical bond between the core and the urethane itself. And my understanding is these are glass-filled urethane cores, which means that it's a urethane-urethane interaction, so should be a relatively good bond. But yeah, so you can see I've based this my core pretty exactly, closely, pretty much copied their core as best as I could, and so this is just the first couple of features that we used to make up that part. So just show you the sketch first of all. The sketch that made that part. It's just a pretty simple sketch. No radii or anything on the sketch. Just so I could start playing with the dimensions and things. Yeah. So and if I turn back on, I'll stop sketch. So there we go. So that's the first body. I then mirrored it around that side, around the left plane, and then I joined those two bodies together so you get rid of that center line. Made it a component, and then what did I do? Then I made the urethane. So the urethane sketch itself is a relatively complicated sketch. It's got lots and lots of detail in it. Try to keep it as simple as I can, but it's all fully parametric and defined. The two splines that we use to define the inside and outside walls of the wheel are fully defined, and I've defined them using angles and the length of the guide line. I don't actually know what the name for these things officially is, but if you haven't used a spline and fully defined it before, I like doing it this way. There are other ways of fully defining and putting measurements on these, but I find this way gives you a pretty nice amount of control over what these things are, and gives you a pretty good feel for what you're doing and how it's actually going to affect things. So the longer you make these lines, the more straight the spline wants to be coming out of that point, and the more aggressively it has to turn away to then meet up with the next point. And also it says the length of the line, but also the position of the line. You can get some really nice tight control over when you dimension them like this. Like if I wanted to make this wheel a much more solid feeling wheel that drifted better, that didn't chatter as much on a slide, but maybe didn't grip quite as much, then I'd make this lip far more well supported. So then I would take this point here and want to move it down so this wheel essentially gets thicker. So if I change that to a 40, you can see exactly what that does to the wheel. That's not a good design. I think maybe let's go middle of the road, maybe 50. Yeah, at least that's manufacturable. Yeah, but you can see there's some weird stuff going on now. I got some pretty complicated curvy weirdness going on. So I'm gonna leave it as it was. Maybe just change this down to 5 degree and make it a little bit longer, and bring this out slightly. 27. Yeah, so that's a much more reasonable shape. I'd probably have to fix this. I don't really like the shape of this curve, but yeah, you get the idea. You get lots of control over your splines when you dimension them that way. Other thing is, this is an offset wheel design, so this is the center line of the core of the wheel. This is where the bearings are going to sit. I'll show you them in a bit, and you can see that these two dimensions are quite different, and that's because this is the outside lip of the wheel, and that's the inside lip of the wheel, and they do different jobs. So we end up with this this weird overlapping sort of design, and they're intentionally overlapping so that I can do a combine move and trim the excess out of the urethane of the wheel and use the core as the tool. So if I look at that, you can see that the target body was this urethane, and the tool body was the core itself, and it was a cut operation, and I kept the tool. So there we go. So that's the main urethane design of the wheel, pretty much done. The rest of it is there's a bit of adding radii and things that happen further on in this design. I should group all of the when you're designing a sub-assembly like this or an assembly, it's nice to group all of the features that are associated with one component or sub-component together, so that you can put them in a nice folder, but this right now is pretty unorganized. Yeah, so next thing I did after finished off with the main geometry of this core and things is I put in my bearings. So this is an import from McMastercar. This is a 608 bearing, and yeah, then I made a joint between the inside edge of the bearing and the center of the core, and then I mirrored that part over to this side. What did I do next? Next thing I did was make the spacer. So the spacer is just a cylinder of generally steel, that I think pretty much always steel, yeah, stainless or some sort of carbon steel, that keeps the races of your the inner races of the bearings the right distance apart. So when you crank down the axle nut, the center races of the bearings don't get shoved together and cause excess wear and drag on the ball bearings. Add some chamfers to it, and then I think this is me adding, yeah, that's where I add all the nice radii to the edge of these wheels. Yeah, now what? There's a joint in there, a move command. What's this? Oh yeah, I'm just adding a nut in. So I think the next move is probably, yeah, it's a joint, me moving that to where it would actually sit. There it is. And then what's this next sketch? I think, oh yeah, so this is where I start to build up the axle. And the axle for precision trucks is different than for a set of cast trucks. If I go back to this video, so a cast truck would have a solid axle that runs all the way from this end of the truck through to here, but it's pretty plain to see that there's all sorts of geometry here that means that there couldn't be a solid axle in there. So you get axles that are screwed into either side of the hanger. This will be a good one to show it with. So I'll reopen that. There we go. So yeah, you can see you get these holes with that would be the threaded surface for this truck. Yeah, I'll show that in a later video. But yeah, so start to build up my axle. I didn't do it with a revolve command. Generally, you want to design cylindrical or roughly cylindrical components with a center line, and then you define the cross section and then do a revolve to make it. But because this refers to other parts so much, I didn't bother. I just basically used a whole bunch of extrudes to create all of this geometry. So this is, so we've got a little extra piece of material in there that is the built-in speed ring, which just makes sure that you don't get any interference between the shield and the outer race and any of this sort of face. So yeah, you only get interaction between the inner race and the axle. Then there's a hex that you would use to tighten the axle into the hanger body. And then I start to add some threads and things. Threads get added, then I add, I believe, the thread recesses. So that's these little recesses in here. Those are this sort of shape, which makes that recess shape makes it easier for if this would be turned on a lathe. So it gives a bit of run out, so that there's not a stress concentration at the end of the thread, and a place for the cutting bit to kind of have a place to run out into and then move away from the work part. Arguable that I should actually make these a bit longer. They don't need to be as short as they are. Then what do I move into? So I did a recess over here as well, and left plenty of meat here for this to be the mating face between this bearing and that axle. I might actually just hide all the rest of this so you can see the axle more clearly. There we go, and I'll get rid of this analysis. So there we go, it's the start of the axle. Then added a few fillets and things. I did a revolve on here to make that a nice circular mating face onto the aluminium of the hanger, and I started to, what else are we doing? Some joints and stuff, and then I added some holes in the ends. That would be a center drill hole. I'll do another analysis. Here we go. Center drill hole, so that you hold this all nice and steady in the lathe while it's being made, and then this is just a hole because apparently it's cool these days to make your axles hollow so they're a little bit lighter. This wouldn't affect the strength of the part in any way, really. This thread is only to hold it into the side of this hanger and just takes a bit of a tension load. This surface here is the actual mating face, which corresponds to that mating face there. So yeah, the thread just holds this axle in and doesn't really take any load. Okay, so then if I turn everything back on, oops. Turn all these parts back on. You can see how the whole assembly goes together. Yeah. So that is how I have designed a wheel for a precision downhill skateboard truck application. So yeah, subscribe if you want to see more videos about this development of the skateboard truck. This is an image of that assembly and this little weird idea I've had. I've actually gone about it a different way. I'll give you a sneak peek at where I've headed with it, and you can see how this design differs from that red shown there is what I started with. That is the same hanger as what's shown here, and then you can see this other one is where I've headed with the design instead, which is it's a bit different. It has a lot of the same features, but yeah, I've incorporated a lot of what seems to be where this sort of technology is at the moment. Taken a lot of inspiration from the Ronin truck, but also taken a lot of design from a lot of other precision trucks that I've liked the look of, and a bit of carryover of design intent from this set of trucks that I had made. So yeah, subscribe if you want to keep watching videos about how I'm designing skate gear. Maybe I'll eventually make them, and maybe I won't. So thanks. I'll talk to you next time.